Greetings everyone, I'm ESPEDILLON. I'm going to present our UML diagram. Our UML diagram represents a smartphone system designed using object-oriented programming principles, where the smartphone class serves as a central controller that manages both hardware components and software application. The smartphone contains essential components such as a battery, network, and storage, which are connected through composition relationship, meaning these parts are strongly owned by smartphone and cannot be exist independent independently. The battery is responsible for providing power and includes functions such as checking the current battery level and determining if the battery is dead and reducing power when it used. Then next is the network class is handle connectivity and allow the user to turn mobile data on or off and checking its status and establish the connection through mobile data. The next is the storage class that manage memory by keeping track to total use of space and checking available space and allowing data to be stored or consumed. Then next is, in addition to these core components, the smartphone also have multiple applications represent as a future object, which is this through an aggregation relationship, which means the application belong to the smartphone but can exist independently. The future class acts as a base class that define common properties and behaviors for all applications, including the name, attributes, and functions to retrieve the name and often the application. To inheritance several specialized application, which is this, extend the feature class, allowing them to reuse its structure while adding their own specific functionalities, which is this, the messenger, camera, music player, browser, and phone call. This includes the messenger for sending message. Is this, it inherits the features, attributes, and components. The next is the camera is for taking photos, then music player for playing songs, and browsers for accessing website, and phone call for making phone call. And next is the calculator, clock, and app star. The calculator performing computation and the clock is for displaying the time. Then each application is override or extend the open function to perform a specific task, demonstrating polymorphism. The smartphone also includes methods such as boot up to initialize the system, and show screen to display the interface. Then function like is clock installed and is calculator installed to check whether a certain of are available, and it can also install applications such as a clock and calculator, showing dynamic behavior in managing pictures. And a special component is the app store, which is this, that inherit also the feature class but has a association relationship to smartphone, meaning this app store can interact directly with the smartphone, allowing it to display available application and support installation process. This relationship is enable communication between objects without strong ownership. Then The diagram demonstrates how the smartphone system is structured in modular and organized way by using key object-oriented programming concepts such as encapsulation, which is the private that hide the private properties of the smartphone, and the composition relationship is the smartphone battery, network, storage, and so on. Then aggregation relationship, which is the smartphone class to features and inheritance to features and messenger clock and so on. Then the smartphone acts as the main unit that integrates all components and features, while each class has a specific responsibility and making the system flexible, reusable, and used to maintain, similar to how the delivered smartphone operates. Thank you.
Marty BORBORAN, and I'll be guiding you through the main class block by block. The main class serves as the entry point or the access point of the program. The first line is the package initialization and then the imports. We import the App Store from the apps package and the scanner from Java util. We run straight to the main class. The main class, we create the scanner, instantiate the smartphone object named Nokia, which initializes all components internally upon creation. We then call boot up to display the startup screen and set the power to CRUZ to indicate the power is on. The while loop, or the only while loop, will serve as the main runtime loop and keeps the phone running as long as power is true and the power in the battery is not dead. Each iteration renders the home screen, reads the user's input, and routes it through the switch statement below. So, for the switch statement, there are, as you can see, multiple cases. So, we start with case 1. Case 1 handles the messenger. It checks whether mobile data is enabled before sending. If it is, the message is sent and 5% of the battery is consumed. If data is off, an error is displayed. For case 2, it handles the phone dialer. It dials a hard-coded number and drains 8% battery. No data check is needed here because calls operate through the cellular signal directly. Case 3 handles the camera. It first checks whether sufficient storage is available before taking a photo. If space is available, 4 MB of storage and 12% battery are consumed. If not, the user is notified. Case 4 and 5 handle the music player and browser respectively. The music player simply plays a song and drains 8% battery. The browser requires mobile data to be active before loading a URL, consuming 10% battery. Here are the from 4, 5, 6, 7, and then 8. Case 6 toggles mobile data. Cases 7 and 8 handle the installable apps, calculator and clock. Both check whether they have been installed before opening. As they default to null if not installed, the user is redirected to the App Store instead. Case 9 opens the App Store, passing the same scanner instance, so it can handle its own input. Case 0, on the other hand, powers off the phone by setting power to false. Exiting the loop, the default case handles any unrecognized input. After the loop ends, the program checks whether it ended due to the battery dying or a manual power off, displaying the appropriate shutdown screen. SC.close is then called to release the scanner resource, and then that concludes the walkthrough of the main class.
Dangal greetings, my name is ABARQUIZ and I'm gonna be explaining about the smartphone class. So, First, this class belongs to the main package, and we have an import. So import allow us to access other classes outside this package. So components contains the hardware of the smartphone. So we have battery, network, and then storage. So next is the apps. So apps contains the application to the phone. So this creates the class. So we name it as smartphone. So next is we have this instance variable. So we declared it as private so that it will be protected and encapsulated. These three have a composition relationship to the smartphone, meaning this is the hardware. So the smartphone can't exist without these three. So it needs each other to work or to exist. So next we have this application. So this one is the pre-installed application or application that will be in the program by default, and this one is the null, or will start as a null. So you need to install it first to show to the interface or to the program. So next we have this constructor. So this constructor, this one, what this do is it passes the smartphone itself into the app store so that the store can know which phone it belongs to. So next is this tree. So this tree is the hardware. So it creates a new objects for the hardware parts of our phone. Next is the applications. So it's instantiated into the app, made into the real object. So what this constructor do is, so when you create the smartphone object, this will be instantiated automatically or by default. So next we have the getters. Because we use private as a access modifier, we need a getter. So we can't access the variables or attributes directly, so we need this. So we just only get getters because we can't edit or set the variable. So only getters or read only. So this is all the getters. So next we have this one. So this method, what this do? So these methods checks if the calculator is installed. So if the calculator is installed, it will return as true, and if not, it will return a false because it's a boolean. This one is the same to this will also, if the clock is also installed, it will return true, and if not, it will return false. So this one is our install calculator. So what this do? So this one install the calculator. So this one have a error handling. So this checks if the data is on. So if the data is on, it will install, and if not, it will display a message saying turn on data first. Next, another error handling. So we have it checks the storage if it have enough storage. So if the storage is enough to install the calculator, it will install, but if not, it will display a error message saying that not enough storage. So next is install clock. So this one is the same to the install calculator. This checks if the data is on, and this one check if you have enough storage. So next is this one, this boot up method. So what this do? So this screen is at the top of the start of the program. So the screen tries to connect to the network. So this is the function of it. Next is we have the show screen method. So this is our main interface, which is our main screen. So this one display the battery level, this the data if it's on or off, and this is the data key. So it's also turning on or turning off the data, and this is the storage. So 3D meaning it needs to have 3 space or 3 because of 3 digit, so you need 3 digit to it. So this one is the screen or the interface. So this format meaning 14 string, so you need to have 14 characters as a default for this, so that if this data key is need to have 14 spaces of characters. So overall, this will give you the main interface of the program. So that's all. Thank you.
Dangal greetings, my name is Mariel Burgos, and now I'll be explaining our class called Battery. So this is under the components package, and this class is responsible for managing a device's battery level starting from full charge and gradually draining as the device is used. So the battery class simulates how real battery behaves and keep tracks of the current battery percentage and provides method to check and updates its state. So we start with the private integer variable called level. So this variable stores the current battery percentage, ensuring that it cannot be directly modified from outside the class. So for the constructor, we have here the constructor battery. So this constructor initializes the battery level to 100%. So this means whenever a new battery object is created, it starts fully charged. Next, we have here the getter method, which is the public int get level. So this simply returns the current battery percentage. So this allows other parts of the program to check how much battery is remaining. And next, we have here the method for battery status checking. So we use here the public boolean is dead. So the method is dead checks if the battery is already empty, and then it returns true when the battery level is less than or equals to 0. So this can be used to stop the main program when the battery runs out. Next, we have here the last method, which is the public void use int amount. So the use int amount method is where the main functionality happens. So first, it reduces the battery level by a specified amount, and if the level goes below to 0, it is reset to 0 to avoid negative values. And then it will print a message showing how much power was used and how much remains. And next, we also have here the low battery warning. So this method also includes a warning system. So if the battery level drops to 20% or below but is still above 0, it displays a low battery warning. So next, we have here the network class. So this is also under the components package. So the network class is responsible for managing mobile data connectivity, similar to how smartphones handles turning data on and off. So other than that, this class simulates mobile data behavior, and it allows us to check whether data is enabled, toggle state, and attempt to connect to a network. So at the core of this class is the private boolean data on. So this variable stores whether mobile data is currently turned on or off. So in the constructor network, we initializes data on into false. So this means by default, mobile data is turned off, just like in many real devices. So we have here the getter method, which is the public boolean is data on. So This returns the current state of the mobile data. So it tells us whether data is enabled or disabled. Next, we have here the for the toggle function, we have here the public void toggle data. So this method switches the data states. So if the data is off, it turns on. And then if the data is on, it turns off. Then it will print a message showing the current status. And then for the last method, we have here the public void connect. So this method checks if the device can connect to a network. So if the mobile data is on, it will print a message saying that it is connected to 5G signal. And then else, if the mobile data is off, it shows a message saying that there is no connection, and it will prompt the user to please turn on the data. Thank you.
Greetings, my name is Aaron CRUZANTE, and I will be discussing the storage class from the components package and the App Store class from the apps package. The first class I will discuss is the storage class. This class acts as the hard drive of our simulated phone. Its primary focus is resource management. It keeps track of how much space is available and prevents the system from overfilling its memory. So at the top, we define two private integers, total and use. By making this private, we ensure that no other classes can accidentally change the storage levels without permission. Next, the constructors. This is the starting point. When the phone is turned on, this method sets the total, which is the attributes, to 128, and then the use attributes sets its value into 0. It sets the stage for all other methods. So next, we have a toGetters method. Since we define our attribute as a private, these toGetters methods is the only way to access these attributes. So we use them to access these attributes since we define them have a access modifier private. So get total to return the total, the value of total, and then the get use to return the value use. So next, the get free method. This method is frequently called by other classes like the App Store. It doesn't just return a value, it performs a calculation total minus use every time it is called to provide a real-time status update. Next, we have a hasSpace method, which has a return type boolean and have a parameter int mb. The purpose of this method is the validation method. It is designed to be called before any data is written. It uses the logic from the getFree method to check if the incoming file size is smaller than the available space. It returns a simple true or false value since it has a return type boolean. So next is the last method we have in this class, which is the consume method. Has a parameter of int mb and string label. So this is the only method that changes the state of the memory. It updates the use variable by adding the mb, and then immediately calls the getFree method within its own system outprint to display the updated remaining balance to the user. The next class I will discuss is the App Store class. So this App Store class is the front end. It acts as the bridge, taking user input into and translating it into commands that the smartphone and storage can understand. This class extends the feature, which means it inherits standard app behaviors. It also has a smartphone and the Nokia object, which is crucial because it allows the store to communicate directly with the phone's hardware. So first thing we see is the constructor. The constructor has a argument, which is smartphone and smartphone Nokia, the object. This establishes a link by passing the Nokia object into constructor. The App Store gains the ability to call methods inside the smartphone class. Without this link, the App Store wouldn't be able to check storage or install anything. Next is the open. This is an overridden method. When the system calls the open, it provides the visual or display the welcome branding before the menu logic starts. Next is the show method. This is the most complex method. Inside its display logic, it calls Nokia get storage that get free. This chain the App Store asks the phone, which asks the storage, which then runs the get free calculation. It's also display the menu of the App Store or user page of the App Store and call the open method, which display the opening or welcome branding. When the user choose, since this method accepts user input, when the user input 1 or 2, the code first calls the Nokia is calculator installed, or if the user input is 2, Nokia that is clock installed. This is a check and balance call to prevent duplicate installs. If that returns false, it calls Nokia install calculator or if the user calls the clock or the user input is 2, it install the clock. Inside that install method, it will eventually call the storage has space and storage consume. This is a perfect example of method delegation. The App Store tells the phone to install and the phone tells the storage to update. So when the user input is 0, it will print or go back to the home screen of the simulated phone, and if the user input is invalid, it will print invalid choice.
Dangal greetings, I'm Ronald Manbiganayang and I'm going to explain the calculator and browser class in our project. And first thing is this package app. Package apps declares that this file belongs to the apps package, a namespace that group related classes together. Other classes can reference this one using apps.calculator. Next is public class calculator extend features. Public means this class is accessible from anywhere. Class calculator defines a new class named calculator. Extend features means calculator inherits all properties and methods from the feature class, making feature its parent or superclass. Next is public calculator string name. This is the constructor, a special method called when a new calculator object is created. It accepts one argument, a string called name. The public keyword makes it accessible from outside the class. Next is super name. This calls the constructor of the parent class feature and passes the name argument to it. This initializes the inherited properties defined in feature. In Java, super method must be the first statement in subclass constructor. And next is this override. This override annotation tells the Java compiler, I am intentionally overriding a method from the parent class feature. If the method signature does not match any parent method, the compiler throws an error, helping you catch mistakes early. And next is public void open. This method, public means it can be called from anywhere. Void means it returns nothing. Open method has no parameter. This overrides the open method from feature to provide calculator specific behavior when the app is launched. Next is system out print, system opening get name. And first print statement prints a line to the console /n, insert a blank line before the message. Get name method is an inherited method from features that returns the stored name. The plus operator concatenates the three parts into one string. Second print statement is prints a second message confirming the calculator is ready. That get name method is called again to embed the app name is in the message. This gives the user visible feedback that the app opened successfully. And next is public void compute string expression. This is accessible everywhere. Returns nothing. Compute is the method name. It accepts a string parameter called expression, which holds the math expression the user wants to evaluate, like 5 plus 3 or 10 times 2. And next is system.outPrint plus get name and computing plus expression. This prints the expression being computed. It formats the output with the app name from get name method and appends the actual expression. Note, no real math is performed here. The method only logs the intent to compute. And next is the browser class. This is the same with the calculator. They're in the same package, which is the app, and this public class browser extend features is it also a child of feature class. And public browser string name. The constructor is called when a new browser object is created. It accepts one parameter, a string called name, which will be the display name of this browser instance. Example is Chrome or my browser. Next is super name. It's the same with the calculator class. This passes the name argument up to the parent class features constructor. This lets feature store and manage the name internally. The get name method use later work because of this initialization, and it also uses override. And this is same with the calculator class. This first print statements an opening message to console, adds a blank line before it. Readability that get name retrieves the name set in the constructor via super. The plus operator joins the parts into one formatted string. And the next print statement is prints a confirmation that the browser is ready. The globe emoji visually distinguishes this from the calculator's output. That getName method is called again to keep the message branded with the app's name. And next is public void serp string URL. Public void accessible from anywhere as usual returns nothing. Serp is the method name representing the action of browsing the web. It accepts a string parameter called URL, which is the web address to navigate to, like https Google. And next is this print statement. This prints the URL being loaded to the console formatted with the app name. The URL variable holds whatever address was passed when serp method was called, like compute in calculator. No actual web loading happens here, only the action is logged. And that's all my part. Thank you.
I'm going to explain the camera and clock classes. The camera class is located inside the app package, and it extends the feature class. This means camera is a type of feature, and it inherits properties and methods from the parent class. In the constructor, we pass the name of the app to the parent class using the super keyword. This allows the camera to use the name defined in feature. Next, we override the open method. This method simulates opening the camera application when it runs. It shows a message showing that the system is opening the app, followed by a message that the viewfinder is ready. The camera class also has a unique method called take photo. This method simulates taking a picture when called. It prints message that a photo has been captured and saved to the gallery. In a real application, this action would also affect the storage and battery usage. Now let's move on to the clock class. So just like camera, the clock class also extends the feature class. This means it shares the same structure and can override methods from the parent class. The constructor works the same way, passing the app name to the feature class. The open method is overridden to simulate opening the clock app. It prints message indicating that the clock is ready to use. The clock class has its own unique method called showtime. This method uses the built-in Java class date to get the current system time. It then prints the current time on the screen. This simulates a real clock application.
Dangal greetings, I'm Dila Cruz Josephine May, and today I will explain the class future in the package apps. So before we dive into the code, I want to talk about how we organize this project. We aren't just throwing all our files into one folder. We are using a professional structure with 3 distinct packages. So number 1 is the main package. This is the brain that starts the program. And number 2 is the package components. These are the UI tools like the battery, network, and so on. And number 3 is the apps package. This is where the actual functionality lives. And that's where our future at Java file is located. And that is I'm gonna explain today. The future class. So by putting the future in the apps package, as you see on line 1, we are telling the system that this is the blueprint for every tool or utility we build later on. This makes our code much easier to scale as the project grows. Let's look at the actual code starting at line 4. We define our class as public class future. On line 5, we say private string name. Now, why make it private? This is a core concept in Java called encapsulation. By marking the name as private, we are hiding it from other package like the main or the components. We don't want those other parts of the program accidentally changing the name of an app while it's running. It stays safe inside this class, and only this class can control it. This prevents bugs and keeps our data clean and reliable. Moving down to line 6 through 8, we have the constructor. Think of the constructor as the birth of a new future. Whenever we want to create a new app, maybe a calculator or a clock, this block of code is what actually builds it in the computer's memory. We pass a string name into the parentheses, and the line this at name equals name tells Java to take the specific word and assign it to the specific instance. Using the keyword this is very important because it distinguishes the variable belonging to the class from the data being passed in through the parameter. It's a small detail, but it's how Java keeps track which app is which. And finally, let's look at how we interact with our future. Since the name is private, we use the getName method on the line 11 to safely retrieve it. This is a getter method, and it's the standard way to share data between different packages in a controlled way. Then, on line 16, we have the open method. This is a simple action that prints a message to the console with a nice hourglass icon. But the most important part is the comment on line 15. It says this method is overridable. Because this is a base class, we can create child classes later. For example, a music player future could inherit from this class and override this open method to play a sound instead of just printing a text. This is the power of polymorphism. We define a general way to open an app here, but every specific app can do it in its own unique way. In summary, the future class isn't just a file. It's a template that ensures every app in our system speaks the same language while staying organized within our package structure. It uses encapsulation to stay safe and inheritance to stay flexible. Thank you for listening.
Tangal greetings, I'm just ESGANA. So in this video, I'm gonna discuss about the messenger class. So the messenger class is in the apps package. So the messenger class is the child class of the featured class. And then we use the extend syntax to inherit the properties of the parent class, which is the featured class. And then in this class, we create a constructor to inherit the name of the parent class. So we use super syntax to call out the constructor of the parent class and then pass the name in this class. So we inherit the name of the parent class. Next is in this method, open method, public void open method. So this method overrides the open method from the parent class using the override. So it prints the message showing that the messenger is opening and then the conversations are loaded. And it also uses the getName method from the parent class to display the name of the feature. And then next is this public void send method. So this method used to send a message. So it takes a parameter which is the MSG parameter string, the text message. So that's the text message, and then prints it into the console. So it also shows the getName method to show the featured name. And then the message. So next is the music player class. So this is also the child class of the featured class, which is the parent class of the music player. So it also in the apps package. and then we use extend to inherit the properties of the parent class, and then we also create a constructor to inherit the name of the parent class. So we use super to inherit the name. So the super syntax is call out the constructor of the parent class to pass the name in this constructor in the child class. So it pass the name in the child class. So we use super to inherit the name of the parent class. And then also we override the open method. So we override the method from the parent class. So it prints the message showing that the music player is opening and then the music library is loaded. So we also use the get name to display the name of the feature. And then also we create a public void play method. So this method used to play the song. So it takes a parameter which is the string song. So the string song is the song name. And then prints the message showing that the song is currently playing. So it's also use the get name method to make the output look like real music, and then get the name of the feature. And then last is the phone call method. So it also the child class of the featured class, and then it also in the apps package. So we use extend syntax to inherit the properties of the featured class, and then we also inherits the name of the parent class using the super syntax. And then also we override the open method. We have the open method coming from the parent class. So it prints the message showing that the phone call is opening and then the dialer is ready. And then we also use the get name method to display the featured name. And then also we have the public void call string number. So this method used to make a call. So it takes a parameter which is the number, which is the phone number, and prints the message showing that the system is dialing that number. So it also used the get name method to display the name of the feature.